Hello, how are you, sir? I hope you are fine. Okay, sir. The task bar, the face detection that the mask is wear correctly or incorrectly. So the first step here in that project, so we will call for the libraries that we use in this our full model. So after that, we use initial learning rate which and epoxies and batch size. These three terminologies our model depend on that. Initial learning rate mean how much our system is going to be learned from our data, and epoxies mean how much time our system will run, how many iterations, and the batch size mean which show that how many data will be go to the as example for training. And next step, here we are going to inspect the divide the data set into categories. The first one is correctly won and the second one is incorrectly won. And after that, with the process, here is followed is our data pre-processing. So data pre-processing, and you also call that the data augmentation. So here, in this stage, we perform some functionalities on image like rotation and zooming and width shifting range, height shifting range, shear range, horizontal flip, and many more. So we perform these pre-processing functionalities on the data set, which is known as data augmentation, to make our data a huge punch for the training our model. So in the next step, here we are going to call for the network, because we are using a live detection. That's why we use the mobile net, uh, which is a library. And after that, here we are going for the constructing our model. So this is the head of our model. Here we define all our parameters, and after that, here we compile our model and train the head of the model. So here you can see that our epochs are running. Training our head mean epochs are running. So how many data? Let's suppose we have 100 data samples, 100 images in our data, and we want 20 epochs. So each epoch contain 5 images, 5 data. So epochs mean the number of iteration, how many iteration will the system go on. And after that, here we are going for the model prediction, that how many our model predicted. So here you can see the incorrectly won all the data, which is already explained in the thesis portion. And again, here we are going to save our model. As we from there we construct a model, and here we are going to save that model, name it mass detector dot model. And here we are plotting some plots, which is the first one is and loss accuracy. Here you can see that how many we lost in training and how many we get accuracy. And after that, some iteration for the necessary calculation. Here we are getting for the F1 score, that how many we get. F1 score mean we are getting around 100% accuracy. So next plot will be for the confidence and recall confidence curve. Here you can see that. And the next plot will be confusion matrix, which is shown here. And the next plot will be the confidence threshold. So here is the model training portion in here. So you can see that, and training loss accuracy also in here. So this is for the result in which we train our model. And now the model we saved in our location, we are going to call for that model in here and check the live detection. So here also we call some libraries, and after that we define a function which is detect and predict mask. So this is the functionality. Here we use Live video detection model. We call our model which we train in here, and after that we call that model and use our main camera, which is faced it already provided in here. Sorry, here video stream SR0. Zero mean the we are using our own laptop camera. If you are using uh, an extra camera like attached camera, so you can use here one or two, which put you are using. So again, after that, here when we run this portion while true, so we connect our camera to in this portion, and when we run this portion, so the model will run and our camera will open, and it will show that the mask, if you wear the mask, you show that the mask is worn incorrectly, sorry, correctly, and if you not wear the mask correctly, so it will show that worn incorrectly. And when you done the simulation, so you can press Q to finish this portion. So here I can see, I will show you how what we get from that. So here is the title of our project, which is mask on detecting correct and incorrect wearing of face mask using machine learning. Here is the abstract. After that, the table of contents and figures and tables, and this is introduction portion. So I'm going to the this is a block diagram methodology. I'm going to the result chapter. Here you can see that the results. The first one is from accuracy and loss curve. We get that results in here, which is also plotted in this portion. Recall confidence curve and confidence threshold, precision confidence curve, and confusion matrix, and again trailing loss. So here we are going for the lab detection test. So as you can see that I am wearing mask correctly, so it will show that worn correctly. Here you can again see that. And if I change my mask position, let's suppose I worn it incorrectly, so the lab detection shows that the mask is worn incorrectly. Here you can see that the mask is worn incorrectly, so it will show that the mask is worn incorrectly. Thank you so much.